Yeah, good afternoon, all of you. So today I'm going to deal in the chapter 1, exact differential equations. So, so this is a very important topic, and also in your BTech, first question is from exact differential equations. Here you will be getting 2 questions. Okay. Now let us go to the exact differential equations. The definition. So now exact differential equations. Let's go to this topic. So, exact differential equation. Now, what do you mean by exact differential equations? Let us see the definition. So, the definition is letter m of x comma y dx plus n into x comma y dy equal to 0. Here I have written m of x comma y dx plus n of x comma y dy equal to 0. That is, m is a function of x and y, n is a function of x and y. I have taken this first order and first degree differential equation. And where this m and n are real value functions for some x and y. This equation is said to be exact. Now, the condition for exactness is, suppose this also can be as m dx plus n dy equal to 0. M is a function of x and y, n is a function of x and y. So, if you take m and if you find dou m partial derivative, dou m by dou y, and if you find dou n by dou x, both must be equal. So, then this is the condition for exactness. So, m of x comma y, n of x comma y are two real value functions having continuous partial derivatives. Then a necessary and sufficient condition for the differential equation m dx plus n dy equal to 0 is, so dou m by dou y is equals to, must be equals to dou n by dou x. So this is the condition for exactness. Now, keeping this in view, now what we have to do here is, now will be to solve this exact differential equation here, you have to follow some steps. What is the step here you have to follow? That is step 1. Okay, step 1. What is the step 1 you have to follow? First of all, whenever an equation is given to you to solve, that is first order and first degree differential equation, first you have to identify what is n. Next you have to identify what is n. Then you have to find partial derivative dou m by with respect to y, and also you have to find partial derivative with respect to x. Both the answers should be the same. That's the first step. After that, after checking that the equation is an exact, you have to find out the solution. To find the solution is phi of x comma y equals to integral of y constant. Okay, integral of y constant. So m into x comma y, okay, into dx plus integral of terms, okay, terms not x. You can write it as like this, terms not x. That is terms independent of x. That is, here in this one it may be purely, okay, in terms of y only, okay, y only, or they may be constants. Okay, not x. Not x means what? X term should not be there, or x, y both combined should not be there. Only purely in terms of y they may be, or they may be constants. So this is the way to find out the solution. Now let us take up a small problem and we will see how to solve this exact differential equation problems. Now suppose a problem is given to you as, that is, solve, yeah, followed. So solve the differential equation. So 2x minus y plus 1 into dx, okay, plus here 2y minus x minus 1 into dy equal to 0, into dy equal to 0. So okay, so 2x minus y plus 1 into dx plus 2y minus x minus 1 into dy equal to 0 is given to you. Now in your examination, when a problem is given to you like this, solve the exact differential equation, first you have to identify. So this is the form of m dx plus this is the form of n dy which equals to 0. So that is the first point you have to see. Now let us see the solution. The solution is what? The given differential equation is so and so, and this is of the form of m dx plus n dy equal to 0. Now what is your m? Where m equals to 2x minus y plus 1, and your n equals to 2y minus x minus 1. Now first partial derivative of m with respect to y, not with respect to x. Many students will confuse. They'll write dou m by dou x, dou m by dou y you have time. So dou m by dou y. So partial derivative this is. So y is there and here x is there. So 0. So y, there is minus y. So what will get the answer? Minus 1. Partial derivative with respect to y. So y is there, constants is there, 0. Then next, dou n by dou x. Here there is x, here there is y. So 0. Here there is x, here there is minus x. So it is minus 1. Here there is x, it is a constant 0. So when you observe here, dou m by dou y is minus 1. Dou n by dou x also minus 1. Therefore, so dou m by dou y is not equal, is equals to dou n by dou x. So here both are equal. So that is equals to what? Minus 1. Okay, minus 1. So when both are equal, what can you say that the given differential equation is, okay, the given differential equation the given differential equation is exact. So after seeing that the given differential is exact, we have to find out the general solution. So the general solution is, okay, the general solution is, what is the general solution? I told you how to write integral of y constant, okay, integral of y constant. So okay, y constant, so m dx plus integral of terms, okay, terms independent, okay, terms independent of x, or otherwise you can write it as not x, okay, not x, independent of x, okay, in n, okay, into dy equal to c, independent of x in n into dy equal to c. So integral of y constant, here you have to keep it as y constant. So integral of y constant, what is your m? M is 2x minus y plus 1 into dx plus integral of, okay, not x I said. Not x means what I said? Here it can be purely in terms of y or constants. Okay. So purely in terms of y means, okay, here there is 2y. So purely in terms of y. Not x is said. You should not write this one. Constants. You should write the constant. So it will be, so into 2y minus 1 into dy equal to c. Now y constant he said. Wherever there is, where there is y, you have to remove outside. So I open the brackets. So integral of 2 is a constant, x dx minus y constant. Y you have to remove outside, y into, when I remove y outside, here there will be 1. So 1 dx plus integral of, okay, integral of 1 dx, okay, here there is 1 dx plus integral of, is purely in terms of y only. So plus integral of, this is 2y minus 1 of dy equal to c. Now, so 2 into x means what? X square by 2 minus 1 dx means x. So it is xy plus 1 dx means x plus integral of 2 dy means 2 into y integration is y square by 2. Okay, minus 1 dy means y equal to some integration constant c. So 2 and 2 get cancelled, and also 2 and 2 will get cancelled. So finally what will get? X square minus xy plus x minus plus x plus y square minus y equal to c. So which is the required solution. Which is the general solution. So now, so this is the method to solve for the exact differential equations. Now when you have seen this exact differential equation, now when you take up a problem, there is no guarantee that each and every problem should be of exact type. What do you mean by exact type? Dou m by dou y must be equal to dou n by dou x. That is exact. And each and every problem may not be exact. So when it is not exact, how to solve? So in such a case, now let us take equations. Next topic. So equations reducible, okay, equations reducible to exact equations. Reducible to exact equations. So equations reduce to exact equations. Now, what he's saying that if the given differential equation, suppose we take a differential equation, m dx plus n dy equals to 0, it is not exact. That means what? Not exact means if you find dou m by dou y, it is not equals to dou n by dou x. It is not exact. It can be made exact by, it can be made equal. Exact means it can be made equal by multiplying with a suitable integrating factor. You have to multiply by a suitable integrating factor, then it can be converted into the exact form. Now I'll give you the 4 rules, and according to the rules, or whichever it is applicable to the problem, you have to apply and you have to solve. Okay, so what is the first one? It is rule 1. Okay, rule 1. So suppose if m, capital M and capital N are homogeneous functions. Okay, they are homogeneous functions of the same order. Okay, homogeneous functions of the same order. So if I take m and n are the homogeneous functions of the same order should be the same. And then mx plus ny is not equal to 0. Then 1 by mx, okay, 1 by mx plus ny is an integrating factor, okay, of m dx plus n dy equal to 0. So what's the first thing he's saying? If m and n are homogeneous functions, so first a problem will be given to you. So you have to identify that problem. So if m and n are homogeneous functions, how they should be? Homogeneous function of the same order. And in such a case, what is the integrating factor? So 1 by mx plus ny is an integrating factor of m dx plus n dy equal to 0. This is the first rule. Now the second rule is rule 2. So first I'll give you all the rules, then basing on that we'll be solving one by one. So rule 2. Suppose under rule 2, if m dx plus n dy, okay, equals to 0 is of the form, how it should be? Suppose if you identify as y into some function f1 of x comma y plus x into some f2 of x comma y equal to 0. And suppose if you identify a problem as, suppose y into some function of xy and again x into some function of xy, then we can say that 1 by mx minus ny is an integrating factor, okay, integrating factor of m dx plus n dy equal to 0. So y into some function of f1 of xy, x into f2 of xy, then what is the integrating factor? 1 by mx minus ny is the integrating factor. Now let us see the rule 3. Okay, let us see the rule 3. Under rule 3 for the equation m dx dy equals to 0. Suppose if it is given to you and it is of form of dx plus dy equals 0. Suppose if you take m and find partial derivative with respect to y, and if you take n and if you find a partial derivative with respect to x and whole divided by n, is 1, that is dou m by dou y minus dou n by dou x whole divided by n. And solution here which is a function of x. It is a function of x only. That is, it should be a function of x, that is x to the power 5, x to the power 7. The function of x only. Y should not be there. Y term should not be x only. Okay. So what can you say that e to the power integral f of x dx is an integrating factor. E to the power integral f of x dx is an integrating factor. So this is what one should find 1 by n dou m by minus n by dou x. If that distributed x only, in fact is e to the power of